Should get the right session number, which is E08, and then just hand it to me on the way out. If I'm not there, just leave it on the chair. Paul?
Thank you. For those of you who have met me before, usually I work on performance topics. Today this one's going to be quite different. My day job is working as a DBA lead, supporting SAP software at BB&T, a regional bank. And typically I do performance topics on OUW. This was something that I wanted to learn about, and I've dived into this, and this was a great learning experience that I'd like to share with everybody here. I am not a data scientist, but I've learned a lot about what it's all about in the last few weeks, months. And I've learned a lot about R language. I actually do know how to spell the word R. That was not a typo. That was a play on words, and people keep giving me grief about not being able to spell R. I can spell R. So if you want to follow me on Twitter, occasionally I do some tweets about DB2, so there's my little Twitter handle if you have an interest. So what are we going to cover today? We're going to talk about what exactly a data scientist is, a little bit about data science. We could spend a week here talking about what data science is, and I promise I will only use 60 minutes today. I put a lot of notes into this because I knew that there's just no way you can cover a subject this broad in 60 minutes. So every slide has notes, and there's a section at the very end that goes into more depth on some of the topics that I figured I wouldn't get a chance to cover. If we get way ahead of time, we'll go into the extra material. If we're right at 60 minutes, we'll let you go, and I am not going to block you from getting to your next session. Why would a DBA care about data science? We'll cover that. I think that is of particular interest to most people in here. How many are DBAs in here? Okay, in that case, you really are going to be interested in that piece of the topic. I'll talk about how R is related to data science and give you some tips on using R and how to use R with DB2. Actually, it could be used with pretty much any kind of DBMS, but since this is a DB2 conference, I only want you to think about using it with DB2 today. But everything that I mentioned, you could apply to some other DBMS. And some of my favorite R functions to use with DB2 we'll cover. So let's jump in at this point. Feel free to tweet anything you see. I know several of you in this room love to tweet, and it won't offend me at all if you're sitting there typing away. If you have anything of interest to type. This is a hashtag that we're trying to encourage people to use, is the IDUG DB2 one. So let's jump in and talk about what data science is. There's so many definitions of this that I only grabbed a few of my favorites. They're all over the place, but they have a lot of commonality I discovered as I started looking at them. In this case, you'll see that, and I'm not going to read all these to you or you'd get bored and go to sleep after lunch. It covers a lot of the data analysis fields like statistics, data mining, predictive analysis, knowledge discovery, and databases. You'll see this repeated in almost all of the definitions, but in different ways. This is the one you find on Wikipedia, and since everything in the world you read in Wikipedia is 100% accurate, this is the one to read. I'm a little facetious on that. Okay, so New York University, which is one of the places that's teaching data science, this is how they define it. And they consider data science as an evolutionary step in interdisciplinary fields, here you see analysis again, that incorporates computer science, modeling, statistics, that's one of the key parts of data science, the analytics and mathematics. And it's using automated methods in order to dig through this massive amount of data that's almost incomprehensible. And now that DB2 will be able to store 256 trillion rows in a single table, there's a lot of data to look at. Okay, as it grows, you're going to see more and more of the traditional disciplines here that start using that. Healthcare is a major user now. The bioinformatics is where you're seeing amazing uses of data. Oncology, the cancer treatment, is the place that you're seeing lots and lots of it, where they're now able to crunch massive amounts of genetic information and pair it up with possible treatments. That's a place that's really exciting to me. But every field you can imagine, the finance field is a big one. That's the industry I'm in. We're doing all kinds of interesting things, but I'm not going to give away any proprietary secrets because Stephen would go back and tell my boss. Seriously, it really is being used in every field you can imagine. Netflix is one that's doing some really cool stuff. And they use some of this to predict when there's a problem by seeing things coming in real time and going, uh-oh, we're seeing all this information coming in. We must have a big problem and we need to get on it and fix it. So it's in real time as well as data that's stored. Okay, I think this is one of my favorites, and it came from a person we all know, Paul Zakopoulos. Well, most of us know Paul Zakopoulos from over the years. And it's a person who loves data, lots of data, and digging in it and trying to figure out really interesting ways of using it. As he says, squeezing every drop of value out of the abundant data, and abundant is an understatement. There's so much data, trying to dig through it is where the challenge is. Let's see. Here's another one where they talk about evolving from the data analyst role and using all of these other techniques, the data mining and the statistical analysis, in order to dig through it. Now, one thing that they talk about here, and I think this is one of the most important pieces, is the ability to communicate. That is, there are a lot of people who are data scientists who lack the ability to communicate their findings, and that is a key important skill if you're going to be a data scientist, is not only being able to do the analysis, but being able to explain it to the business folks who need to act on what they find. That's a key skill, and I'm glad they mentioned it in that definition. Okay, so this one, and a lot of us have run into IDUG over the years. She describes it as a part analyst, part artist, which I think is another interesting way to look at it. This is an evolving science, and it's going to continue to evolve over the years, even though it's definitely a lot of statistical concepts that have been around for many, many years. This is now starting to use the computer power that we now have access to be able to spot the trends. 5 years ago, most of what they're doing now with data science would not have even been possible. Okay, this one I like. Data scientists are cool. Computer World says it's the hottest job out there. And if you pull up my session, you'll find the link and can go read the whole article about why it's the hottest job going. We can debate whether or not it is, but they've got some good information about it. So why would a DBA care? Well, I put that as big as and as important as I can possibly make it, jobs. We all want, well, I think most of us want to have a job. We certainly want to be paid so we can exist. McKinsey is saying that they think there'll be 4 to 5 million US jobs involved needing these skills. Now, what they're not saying is that you're going to have to be a hardcore data scientist. A lot of data science is moving into other fields, marketing, for example, and there are going to be tools out there that make it possible for a lot of people to do data science work. That you're not going to necessarily have to be a PhD in statistics in order to be able to use some of this, that it's going to continue to move into the products. And I'm thinking the 190,000, those are going to be more of the hardcore statisticians, the PhDs and those kind of people who dive really deep down into this, plus the people who build the infrastructure to make all of this work. I do a lot of work on the infrastructure side and getting environments set up. So for me, that's the real interesting part about this. But I needed to understand the environment in order to understand how it was going to affect me personally. This one is also really cool. How many DBAs would like to have more work-life balance? I think most of us would like that part. And because of the nature of this job, there's a lot more work-life balance in this than in some of the other facets. Now, this one kind of blew me away. How many times have you ever heard of a computer job being the sexiest job of the 21st century? That doesn't happen in the IT world. That's kind of cool. So, now that we've kind of talked about why it's important, why we might be interested, now I'll dive into a little more of the techie details of how you use it. And believe me, I am not going to get into super detail, but I'll show you some techniques that I played with that you can expand upon. There are two languages you hear about used a lot with data science. There are other ones that you hear a little bit about, like Scala and some of those, but R and Python are the two you hear the most about, and they've been around the longest. Python is a very good general purpose language. It's very good if you're working on preparing data, doing the ETL kind of functions. It's really good for that. Both of these are scripting languages, or at least they're ones that are interpretive, let's put it that way. Python is more the scripting, and R was written for statisticians. How many of you have ever looked at R? Okay, so you probably know that it's somewhat cryptic. It's a very interesting one, and I'm told by some people that have worked with SAS and R that they're similar. They're different. Years and years ago, if you go back and figure out where R came from, it came from another language called S, which then evolved into something as somebody wanted a free language that they could distribute to all over the place, everybody could use it, and it's continued down that path where SAS obviously is not a free language. So R is used by all kinds of statisticians, and pretty much any kind of statistical work you could imagine can be done in R. There is probably not a statistical function that isn't in there, but if there is, people have written other packages on top of R to handle making it easier to use the ones that weren't in there. When I said thousands of packages, there at least, well, the last time I looked, there were almost 7,000 at this particular place. A CRAN is what it's called, and I'm not going to try to say that whole name. But you can go out there and download anything that's on there, and the hardest part that I have found is figuring out what you wanted to download and figuring out which one is going to do what you want. It's not getting it. It's very, very easy to grab them, but digging through 7,000 takes a little while. That's the biggest part to me. And if you find something that's missing and you want to build it, you can freely build your own and put it out there for everyone else to use. What I have found is it's somewhat challenging to learn. The learning curve is somewhat high on doing this, and I thought I was a reasonably decent developer. And I've spent about 2 months trying to dig in and really learn how R is working, and I still have a long way to go, but I can write some fairly basic programs now that can actually do quite a bit. When I say that, what I mean is that you can write a very small program that can do a lot of fancy work with just a few lines. Now, when you start looking at them, you'll see that the lines in there are very cryptic. It's not that easy to pick up somebody else's program that's not documented and figure out exactly what it does. That's kind of what it's about. It works with many DBMS. It's, I think, the only one that I have found so far that we might have ever heard of that I have not seen any kind of connection to as IMS, and that's a very different world. But every RDBMS you've ever heard of, every NoSQL database pretty much has a way to work with R. So when I say what I'm going to show you works with DB2, you could literally pick that up and you could put it with whatever's your favorite of those. Not that I would encourage that, but it is possible. But not only does it work with DBMSs, almost every unstructured type of data you could possibly imagine also can be worked with within R. So it's a very, very flexible as far as feeding data into it. If you have data in Hadoop, you can use R. If you have any of these different types, Excel was one of the more interesting ones. So if you have really neat spreadsheets, you can feed those into R and work with that data as well. Another really interesting one is web data. It can actually grab information off of web pages and do analysis on what's out there. Now, as I mentioned, it has, in my opinion, a fairly high learning curve. Luckily, there are a lot of resources out there to help you learn it. And because it's becoming so popular, it feels like every day there's another place that can help you learn it. One of the best that I have found, I don't know if anyone got to go to Pete Sooner's session earlier, but he talked about Coursera. And he's actually the guy that pointed me to Coursera and told me there were some very good pieces of learning out there. This was actually written by some people that work at Johns Hopkins. And so a lot of the information that you'll find out there is in the bioinformatics area because that's the kind of work they do. And they actually take work that they have done and they incorporate it into their courses. Now, the one challenge I found is while it may sound like these are fairly beginner level topics, they're fairly advanced. And what I found very quickly was you needed to know R reasonably well to really jump in, and you had to have a decent knowledge of statistics. So I'm going back and refreshing my statistics. I thought I knew it fairly well, but it's been a few years, and now I'm having to relearn the advanced statistics. But these are some of the courses they have. The Data Scientist Toolbox is a good introductory one. It really doesn't go into R, but it talks mainly about the whole what's out there to work with. Then the R programming sounded like a pretty beginner thing. I found it to be at least intermediate. So if you haven't done some R programming, that one will keep you busy. So that's what Coursera has. Coursera's prices are anywhere from $29 to $39 a course if you want the certificate. If you didn't want the certificate, these are still free.
Is that remote?
What's that?
Remote classes? Yeah.
Those are all remote. A lot of the information out there you'll find, they call it a MOOC, and thousands of people are taking these. And what's really interesting, at least with the Coursera ones, they have forums out there and people are posting questions all the time. And you may have 2,000 people taking the course at one time, but you take it at any time you want, and all the content is out there in video form, and take it when you want. Big Data University. Hopefully all of you have used this resource at one time or another. It's a great resource developed by IBM. Some great courses out there. Right now they've got a couple that were developed by a different company that they're partnering with. So it's another good resource. And I've taken several of these and found them to be very, very helpful. They take anywhere from 2 hours to 8 hours to take one of these. Some of them might take a little longer, but this is another good resource. I think the best part of that is they're all free. And they're high quality. It's not like you're getting a low quality just because they're free. So this is another source. If you want to see how you can use it for some of the lower level, when I say lower level, introductory statistics, this one to me was a really good one to look at. And all of these are in your session thing, so you don't have to scribble all of this down. If you want to take pictures, that's okay too, but you can download it. Swirl is kind of interesting because you can install that and you can do it. You turn your R Studio into an interactive learning environment, and it teaches you, it'll pop up questions and you type in the command and it'll tell you if you got it right, or when you finally get frustrated, it'll tell you the answer. Which
Sometimes.
Sometimes it'll sit there and like almost an infinite loop, and you're like, oh, come on, I just want the answer. So you keep giving it wrong answers, hoping that eventually it'll tell you it's wrong, move on. But I found that to be pretty useful. If you get really serious, there's some excellent data science master's programs out there. The two top ones, those are both in my local area, so I'm fairly familiar with them. NC State's probably one of the best in the country, if not the best in the country. Unfortunately, it's a 9-month full term. You can only do it full time. I don't want to take 9 months off from work to go do it, so that one's kind of out. But it is an excellent one, and it's tied very closely into SAS because SAS is right there a few miles away from them. So they're all over the country and they're popping up like crazy. Everybody's realizing that data science is hot, so everybody wants to put out programs to get people prepared. Okay, now we're going to dive in how to use this particular language with DB2, and there are various ways to accomplish it. I'll cover one in here, but I'll give you some high-level ideas and point you to some places about how to do additional ways. You can connect to DB2 and pull all the detailed data back into R. That has its limitations. You're not going to pull a billion rows back into your environment too easily unless you want to see your machine blow up. I've actually seen techniques like that used in the old days of different languages where people actually did run a select asterisk with no where clause and just about blew up a machine pulling back billions of rows, or at least at that time, millions. So that's not necessarily the best way to do it. It's a good way to experiment, but not a good way to build a production-ready kind of system. You can also process the DB2 data on the server and return the data to R for additional processing. That actually works pretty well. That way you can use your where clauses to limit things, you can tell it what columns to pull back, and you can minimize how much data comes back. You can use some group bys and summarize the data before you even bring it back for additional statistical processing. One of the more interesting techniques, and this was talked about last year, and this is where I really got interested in R to begin with, was this F17 course, session. And it was how to run a stored procedure in DB2 and do all kinds of work over in DB2 itself inside the engine. And if you want to know all about how that was done, hunt that little session down on the IDUG website, and it'll give you a lot of good information. The person who did that article actually is doing a couple of sessions here, and his name just blipped out of my brain. But if you go on the grid and you find anything on R, and it's, I think, Robert, he's the guy who wrote that, and he's got a couple more sessions this year talking about using R. So if you want to dive into it even further, that's where you would like to go. In fact, there he is. I did have his name, Robert, and he's doing a session D10. So tomorrow morning, if you have time on your schedule and you want more R, he really knows this subject extremely well. Now here's the challenge if you're trying to use the technique where you do a select asterisk with no where clause and pull all your data back. Here's where your challenge is. R has a limited memory. If you're running it on your laptop, you're limited to whatever your memory on your laptop is, and usually that's not huge. Even if you're running it on a big server, a big Linux server, there's still only a limited amount of space you're going to have in memory, and it's doing all its work in memory. It's not doing this on disk. So if you're just trying to experiment and you're doing this on thousands of rows of data, it doesn't really matter which technique you use. It's when you start processing millions of rows it starts mattering. What I'm going to show you in my presentation is just the techniques. And then those would have to be moved into one of these other methods. So before we jump into it, R has some terminology that you kind of have to understand when you're reading through all these different resources, because they use words in R that mean something totally different in other languages, which can really throw you if you don't know what in the world they're talking about. They talk about vectors a lot, and a vector is simply a sequence of numbers. But they use that terminology a lot. And here's simply how you define a vector. You just use the assign symbol, which just looks like the less than and the dash, and you assign it to a variable, and then you have this little C function. And do not confuse it with the capital C function because they're totally different functions. That's another fun part in R. It's all, you can have upper, lowercase, and they mean totally different things. C is one that I just happened to run into that had two different meanings, which was kind of clever, but concatenate is what that one means, and all it say is, okay, in this case, take 10, 20, 30 and load it into this variable, and now you can operate on this vector. That's a very basic kind of thing. If you want to see what's in that vector, you just type X and boom, it prints it out for you. So it's a very easy to work with. Data frame is something you'll see a lot, and if you want to think of this as a spreadsheet or a relational table, both are pretty close to what it is, but you'll see the use of data frame a lot. And it's really a matrix is what it's defined as. And each column can store data of a different type, which is kind of like a relational table or spreadsheet. And a data set, that's another term that means things in other parts of IT. All it is data in a file. So anytime you see the word data set, they're just talking a file with data in it. Okay, I mentioned that there are thousands of packages, and you probably wondered what in the world a package is. Well, this is not a DB2 package. It has nothing whatsoever to do with the DB2 package definition. All it is it's a collection of different functions, data, and compile code that you put in this unit, and then somebody can download it and work with it. And often it has these little data sets embedded into a package. So it's just this downloadable piece. Once you get it, it stores it in a library, and then you can operate on it. And to figure out what you've actually got in your environment, you just use this install.packages command, and it'll list out everything that you have. Before you use it, you have to load it. Otherwise, it's installed but not loaded, and you can't use it. To figure out what is loaded, you just use a library and a parenthesis. Pretty much you'll find everything is a function, and you'll see the name and the parenthesis pretty much in everything. And when you start reading about it, often that's how they talk about it, and they'll just always list it out with the name and the parenthesis. Generally, you pass something in the parameters, but often they have quite a long list of parameters you're passing in. So, how would you connect to it? Well, there are two different major ways of connecting. There's RJDBC, which is just their flavor of JDBC, and there's RODBC, which is the R flavor of ODBC. So if you're familiar with either one of these, you've got a major head start on using R, because this is simply their implementation. I generally use the RStudio, which is an IDE. It's a nice little environment to work in. Of course, it's free. Everything else, most things in the R world seem to be free. In the notes in my presentation, I talk about where you can get this RStudio, what it looks like, and it's just a handy way of working with R. So once you've got that, you just run this install.packages, and generally when you're installing a package, it looks kind of like this. It's just install.packages, and then it's in parentheses and quotes around it, and that's installing that package. That's all there is to it. The nice thing is, that thing that I mentioned earlier, CRAN, it's a huge repository that's out there somewhere. Actually, in your studio, you can define which one of the locations to go to. They've got it mirrored all over the place so you can get fast connections. But after that, and you tell it which one you want to use, you never have to tell it that again. You just say the name, and it goes out there, figures out where it is, and pulls it down into your environment. So it's very, very easy to work with. Once you've got it, in theory, All you have to do is use a command like this to get it working. I say in theory because it doesn't want to work on my machine, and I got this little guy. So I kind of crashed and burned on the JDBC side, but that was okay because I didn't really want to use Java to program what I was doing in R. So I moved on, and I got the ODBC one working just fine. That was actually a breeze. And there are two different ways you can work with the ODBC on your Windows machine, or probably Linux. I was doing it in the Windows world. You can either define it within Windows as a data source by going in, and I don't know if anybody's ever defined one. I've done it a lot with DB2. You can set it up on the control panel underneath of the ODBC data source administrator, define it, you tell it what database you're working with, that kind of information, and then from then on you can work with it. If you don't want to define it, there's a way you can do it at runtime. And I'll show you in a few minutes how you can define it that way. So you can either predefine it and have it out there. You might not want to do that if you had a whole bunch of them, and you've now got this whole clutter of 50 databases out there. You might want to do it from the runtime method. So either way works. I personally wanted to do it the simple way. I defined it underneath of the ODBC data source and had it available. And as you might guess, I'm using the sample database just because it's there, it's easy to create. And I didn't want to give away any proprietary information. So I wanted to stay out of trouble on that. So in the RStudio, once you've got that in there, all you do is you do library RODBC, and boom, now you've got your RODBC driver and everything is loaded up in memory and ready to go. If you want to see all the different ODBC functions, if you don't happen to have them memorized, and there are quite a few of them, you can go here and it'll give you a list of everything that you can do with RODBC. As far as I know, everything you can do in ODBC, they have an equivalent here, and everything works exactly the same. If you want to see what sources were already cataloged, I guess you would call it, you can do an ODBC data sources in parentheses, and it'll list out all the ones that you've already set up. In this case, I could see that I had mine under DB2 copy 1, and if you've ever installed DB2 on a Windows machine, you're familiar with that name. Once you've done that, you set up a connection string. This is a simple way to do it. My password is actually not that, but I just wanted to hide that and show you how to do it. But once you've got that set up, to test it, you simply set up a variable and you use an ODBC query, pass the connection string, and in this case I just wanted to set the current schema. And once I set that, I wouldn't have to specify Paul.whatever from then on. So I just set that. To make sure I can actually read the data, I simply put result and I point to SQL fetch in the connection string. If you've used a sample database, you know there's an employee table in there. You run that, and then you type result, and boom, it'll show you all the rows from the employee table, and that's a super simple example of how you can get data back. This is kind of violating my concept of pulling all the data back, but the employee table is really small, so I knew I'd get away with that. I knew if I went for a 10 million row table, I'd still be running on my machine. So if you want to get the detailed information, there's something called ODBC get info, and you tell it the little connection string. Most people are not that interested in exactly what ODBC version, but if you do need that, it's right there, but it will tell you the source name and that kind of information. This one I actually found pretty handy. If you want to know what tables are out there in the employee database, you can use SQL tables, and it'll show you all the different tables that are out there that you can work with, so that's a handy one. Be careful if you run this in certain databases. Never ever run this if you're working on an SAP database, because you're likely to get 100,000 of these back, and I am not exaggerating, and it'll run for the next hour. Be careful with this one. And no, I did not do it. I knew better. Usually I learned by breaking things. This one was one I knew not to do. If you want to know what columns are in the table, this is similar to, say, a describe kind of thing, but you can just use SQL columns, tell it what table you want, and it'll list out all the columns that are in there. Now, what you're probably also realizing is you can use R to build SQL by pulling back information like that and then feeding it into another query. Here's another example of how to do a fetch. And this is, so once you've got your data into your variable, you can then do things like extract out pieces of that information, and this is how you can do it with a print statement. And all that's saying is I want columns 1 through 4, and I want it only on the first row. So that's where your row is, and your columns are right there. And then you can say row.names equals false, so you don't end up getting all your row the actual column names and that kind of information coming back. If, say, you wanted to go for row 42, and I just happen to know there were 42 rows in that particular table, the 42 references that, and even though you're only pulling columns 4 and 5, where you could have put a comma between them, a colon works just as well. So there's some funky syntax things that you'll discover as you're working with R. Sometimes they're very specific, and sometimes they're kind of wide open, and I think I broke every way you could do. So here's another example that's getting a little more interesting, and the reason I say interesting, now I'm starting to move toward using some of the R functionality versus the RODBC. So I get the data into result. I happen to know, and this is something that bit me a few times before I finally got it through my thick head, is what you will get is a data frame. And that's that little spreadsheet-like thing. But what I also discovered, there are a number of R operations that will not operate on a data frame. It's not quite as clear what's wrong when you get a message like this one. Argument not numeric or logical. Well, to me, that didn't say your data's in a data frame. You can't operate on it. It was my data's not numeric, and I knew my data was numeric. That kind of threw me for a while, and I learned that there are places like Stack Overflow that have explanations for everything in the world. Stack Overflow will be your friend when you're learning R. Unfortunately, I'd hate to tell you how many hours it took me to solve this problem, even looking through Stack Overflow. But it's actually a very easy problem to resolve once you know what the problem is. And what I had attempted to do was I was trying to do a mean of the data that I'd pull back in data result. And what I'd pull back was salary, and I wanted to get a mean of the salary, which is a pretty common kind of operation in the statistical world. So how do you solve that? Well, it's actually pretty easy. There are some ways to find out the attributes of the objects, and everything in R is an object. So if you like object-oriented programming, you're in your element, because it's all about objects. So what you can do is you can do attributes of that variable, and it will print out a bunch of somewhat cryptic information, listing the name, and names is simply the column name. What's in your rows. But here's where the key was. The class of data is a data frame, and that was a good clue, because then I did a search and said, why can't I do a mean on a data frame? And it says, oh, well, you can't do those kind of operations on a data frame. This is how you fix it. Before we jump into how you fix it, these are a couple of different things you can find. You can figure out how many rows you have, how many columns you have. This simply means you've got one column in that result. That means you have 42 rows. But here's how you do it. You're essentially casting the data into a different type by using this. And what you're saying is, I want to take my data frame, which has this name, and I want you to make it a matrix. Once you've got the matrix, I want you to do the mean on it. So once you have that answer, you save yourself a few, sometimes many hours of frustration. And then that calculates the mean for you, which is that. If you don't believe it, you can take that same kind of data and throw it in Excel and prove that that actually is a valid thing. I'm one of those people that doesn't believe anything until I prove it. So if you don't have the ability to create the data source on the client, this is how you can get around that. You're doing it at essentially runtime. You just give it the database name, host name, port, username, and my password is not a bunch of question marks, but I'm not telling what it is. And then you can use something called paste. Paste is another funny one. I mean, paste is not used the same way you use in other languages, but what it essentially does is it concatenates vectors. So you take a whole bunch of vectors, or just a piece of data that we've talked about before. You put all that into a variable type. It doesn't matter what you call it, but this was my connection string, so I called it con.text. Pasted all that in, which was just a concatenate operation. And then I fed it in like this with RODBC driver connect, pass that string in, and boom, I had my connection. So that's a way you can do it if you want to do it without having to go through and predefine all of your connections. You can do that very, very easily, and then you can operate on it exactly the same way as you did before. So these are some of my favorites that I started working with. DB2 has a few statistical functions. It doesn't have a lot of functions, and that's one of the reasons you may want to use R. DB2, actually every DBMS is pretty limited on the statistical functions that are built in, so you have to find another way of using statistical functions if you're trying to work with it in the database itself. These are the ones you would find inside of DB2 itself. R has, well, I said hundreds when I was starting to do my research. I'm pretty sure it's in the thousands of various ones. If you've ever heard of anything in statistics, you will find that it's already coded in R somehow, and it's a matter of figuring out which ones you want to use. I had no idea there were that many statistical operations known to man until I started looking at it, and there were pages and pages of them. And then if that's not enough, there are thousands more R packages that extend the language. Here's a very basic one, mean, that's just an average. And this is the real simple way to calculate it. And I'm going to go through these pretty quick because they're not that exciting. So to calculate the mean of the values 1 through 100, you simply use mean 1:100, and boom, you'll get your answer. If you can also pass in a vector, just like I did there, and these vectors could be way, way longer than 3 characters. As far as I can tell, it's unlimited how big it can be. And that simply calculated the mean for that particular value. And I know that's not super exciting, but you can use any function the same way. So no matter how fancy it is, it's used with the same sort of syntax where you say the function and then you pass it the argument. You can, and here I'm doing is static values. Very rarely would you ever be operating static values. You'd be pulling them in from a database or other data source and feeding them in. This is just simply an example of how you see it. Typically you would have defined it with the C function and then passed it in from the database. And a lot of times you'll have a function that goes out about that wide and you just pass it and it's nested. It's great for nesting functions, and as much as your brain can handle on the nesting you can do. You literally can have most of a program in one line. It's unreadable at that point, but you can do it. I don't think we need to explain the median part any further. Variance is another common one in the statistical world where you're just trying to figure out how far a number is from a mean, and this is simply how you do that. If you don't believe that is correct, you can go in Excel and calculate it, and you will get the same answer. Rounding is slightly different between the two between R and Excel, but you can fix that. Standard deviation is an extremely common statistical function, and I show it here. It's represented by this little lowercase Greek letter sigma, and that's the simple way to calculate a standard deviation. I'm just showing these as certain examples because these are fairly basic operations, and any other operation that you're doing follows this pattern. Here's another case of using a vector. You put the 4 values into the vector, and I was just trying to be humorous and call the vector vector. Going back to the old airplane movie. Have to have a little humor in learning this because staring at R at midnight, it is, you have to add some humor or it drives you crazy. And believe me, my wife and daughter kept going, "What are you doing? Why are you playing with that silly thing? It's time for bed." But I really got into this and was trying to learn how all this operates. And here are some real basic ways that you can do it. And I showed you how you could do it with static values. This is simply feeding in those same exact functions using variable names instead. But you could also be pulling it in from a data source and just feeding it directly in there and skipping, putting it into a variable first. There are many, many different ways you can code R.
And can the vector be defined as a DB2 function of, or an average or something like that?
The question is, can the vector be a function in DB2? My guess is it can.
Or an SQL statement, basically, yeah.
Yes, actually, I know it can, because when in my example where we were doing like SQL fetch, that was actually pulling it in, and I could have immediately taken that value and passed it on in.
Good.
But I would have had to convert.
Oh, yes, yeah.
I would have had to do that casting, so it would then pass the data frame, convert it into a matrix, and feed it on in.
Okay.
The only challenge to doing that is now you get these statements that are a mile long, and you look at it and go, "Good gosh, what is this thing actually doing?" So while you can make super, super long things, sometimes it makes it harder to understand. But yes, you can do what you're talking about. Okay. I don't know how many of you have ever worked with econometrics. I'd never heard of it till I went through an MBA program and we did econometrics on all kinds of stuff. Econometrics is simply using mathematical functions, statistical concepts to take economic data and turn it into something useful. Believe me, the definitions are a little more complex, but that's what it's all about. It's looking at data and making predictions based on the data. And in a few minutes, I'm going to show you one that I had a little fun with, a little prediction. Regression analysis is a tool that's used very commonly in the econometrics world. I see some people nodding their heads, and they're probably going, "Oh my gosh, you're taking me back to that world." The funny thing is, when I first did one of these, I did not like it. I just really didn't like that stuff. And then I realized, wow, this has got some really interesting power, and it actually works. That was the eye-opener for me, was when I was able to actually use an equation that came out of here and actually predict something, and it actually matched reality. So it has some power, and economists use this all the time. And they're beginning to do things like use R with econometrics. So what it essentially is comparing two variables and estimating this equation. And when I say two, it can actually be on many, many variables. And then you have the multivariate regression analysis. Typically, two will actually give you the most value or the most predictability. But sometimes other ones will give you additional information. And I did a little experiment that I'll show you where I did try to do some adding more than two to see what would happen. If you want to play with these and you need some data to play with that's econometric, there's something called ECDAT. No idea exactly what it stands for, but it's another package. You install it, and instead of it just being a whole bunch of functions, it's mainly data. and you're bringing back all these different data. When you go into this ecdat.pdf, it'll explain what exactly is in there, and I was looking for something interesting to play with that was in there, so I loaded it into memory and started playing with it and looking at it. And I found one that I thought would be kind of fun to play with. It was called ice cream. And that caught my eye because I personally like ice cream. And some of them were extremely boring, saying, okay, I got 10 minutes, so I'm going to speed up some of this. What this data set had was the consumption of ice cream per person in pints, the income, the average income per week, price, and temperature. And I wanted to do some analysis with this data to see if any of these variables meant anything to each other. So loaded it into memory and this is another way of loading it into memory. It's just data in the name of the data set. Looked at the data to see what it was. This is only the first 18 of the 30 observations, and you could see that that's what the data looked like. If you wanted to just kind of do some high-level looking and eyeballing to see what you had, that's a way to do it. So I started coming up with some questions, and data scientists do this all the time, but their questions are a little more interesting. Well, I don't know if they may not be more interesting, but they do come up with these questions and hypotheses, and then they go cranking through the data to prove whether or not what they're seeing can help them. So I started wondering, does the consumption of ice cream have anything to do with income, price, or temperature? I kind of figured that people's income would have some effect on how much ice cream they could buy. I personally like ice cream better when it's hot outside, so I figured, well, maybe the other people did too. So to prove that, I started cranking through it using some of these R functions. Attach is how you put it up there in a way that it makes it really easy to reference. There are ways to reference the data within this in other ways, but attach made it really simple. If you want to see a histogram, and this is one power of R, the graphing capabilities are excellent. I don't know of any language that I can just type hist in a particular item and boom, I have a histogram already drawn for me. Excel can do these kind of things, but not quite that easily. Beyond that, you can do things like scatter plots. Those are extremely common, and all it is little dots of where the data with the two variables are on the graph. The plot function is used in that, and if you're using the RStudio, when you type that word plot with those two variables, it actually launches a little window up there, and boom, you've got this cool little chart. I like that I can do it that easily, so we've plotted out the different variables here. That's still not too interesting yet, but it's going to get more interesting. Then you're able to draw a linear regression line, and it's actually calculating all this linear regression for you behind the scenes, and it graphed it out for you all in that one little line. That's the kind of power that you start getting with R. Is if you had tried to do that on your calculator, you'd be calculating for a while. When I first learned it, I had to do it on a calculator, and it was not fun. Then we got to do it in Excel on some of those, and then it got to be a little more fun, but this makes it really fun. So this is just drawing it out, and you use a title to pop a little title on here. As I mentioned, one of the things that's challenging is communication, and being able to draw really cool little graphs like this and a few instructions to be able to put into a presentation is really good for the communication side. So I started doing some experiments. This one, it's kind of a flat line, and these dots are all over the place, so I could look at that pretty immediately and go, it's not helping me very much. But when you start seeing lines that look like maybe they're showing a relationship, it's kind of handy. Now, I'm not going to go through every single one of these in great detail because we're kind of low on time. But you can see the power of, at least I could start seeing the power of what I could do with just a few instructions. And that literally would have taken me hours to do in some other ways, and it took me seconds to do this way. Now this one, to me, starts looking like it's much more where I'm seeing a real good relationship and the dots are getting closer to the line. So I'm going, now it's starting to get more interesting. And here was where I had temperature. So that was kind of proving that temperature might have something to do with the consumption of ice cream and why people would buy more when it's hot. So then I wanted to see, well, okay, now I'm beginning to see this. Now I want to really prove that it's actually working and that I'm actually predicting something. So you do something with a model, call this little statement, and it lists these things, these coefficients in your intercept and your temperature, which if you're not a statistician, your eyes have glazed over already. But here's where to me it got interesting, because you get this little equation, which says consumption, and you use this as your static value, and you calculate this when it passed temperature. So I said, okay, I wonder what will happen when it's 72 degrees, what the consumption is. So I calculated that, and then I went back and looked at the real data. And the real data says that the consumption was 0.443 if the temperature was 73, and my little equation is 0.43. So that's actually pretty close. Thank you. Those are the kind of things that you can start getting out of this, and economists love that because they go, oh, well, now we can say, when the temperature is rising, we need to do more marketing of the ice cream and various things like that. I mean, that's one of those real simple things. All of us would say that's just common sense. But there are a whole lot of other items that are a whole lot different. Florists love to know how many roses that they should buy before Valentine's, and they're actually regression analysis equations that they can predict pretty close how many flowers they should buy so they don't have too many and they don't have too few. Those are the kind of things economists stay up late at night doing. If you want to try it and throw some more equations in there, you saw that I had three different variables. That I had different variables, so just for fun, I threw some additional ones in there, and it's actually very simple to keep adding them. All you have to do is a plus and just keep stringing it out there. So instead of having to do a whole lot more work, it's super simple to go do some additional analysis, and then you get these other coefficients. So I figured, well, okay, let's test it. So I built out this equation, put in all the different things, calculated it, and in this case, I said, well, the income is this, the temperature is this. I calculated it, and I was somewhat disappointed. Because now my calculated value is 0.415, which got me further away from the real answer. So at that point I realized, well, that extra information does not help get me anywhere closer to the answer. It got me further away, so I know that's not a good equation at that point. I know this is very basic as far as the equations, but the work the economists do is way more fancy, but they're still doing the basic, what I just did, and the better they are at this, the more money they make. Seriously, an economist that can make these predictions accurately is worth their weight in gold to a company. If they make them badly, a company may go bust. It's that simple. So to really prove that this would all work if I did it in DB2 instead of pulling it from an ECDOT data thing, I took that data that had been in there and I loaded it up in a table, and I had the instructions for exactly how I did it. So I now have an ice cream table, same data is in the flat file, and then read it in there, built the equation, same way, attached the result, and now I have it in a result. And then I was able to plot the same kind of information, and I'm now pulling the data out of DB2. And so you can do all kinds of playing to get that to work. If your data is not in DB2, you can put it there. If it is in DB2, it makes it so much easier to deal with. So as I was learning this, and I just point out a few more tips before I wrap up because I'm about out of time. This is the best book that I have found right now. Everything that O'Reilly puts out is good, but this was especially good for learning R. R for Dummies is also good. Don't let the title insult you, but it's a really good book, and I'm about 90% done with that one. But I still, this was my favorite of the two. There are hundreds and hundreds of resources out there. I put a bunch of them in your notes so you can learn more about R, but here are some of my favorites. So what we covered today, what is a data scientist? They're a person with a lot of imagination. They're out there exploring these massive amounts of data and distilling it down into some really interesting values. And not only that, they're asking all kinds of good questions. That's another item that's important for a data scientist, is not just to be able to see that there are questions out there, but what is the good question? What is going to add value to their company? What is the most important question to answer? DBAs care about data science because there's all kinds of work coming this way. That's for sure one of them. And making your company successful is a even better reason to be interested. The relationship of R to data science. R is probably the most common language right now with R, especially if you're focusing on the statistical side. Python is extremely popular if you're looking at getting the data ready to operate on. And I showed you some examples of how to use R with DB2 and some of my favorite functions to use with DB2. At the end of the presentation, we don't really have time for questions, but I'll talk to anybody after the session that wants to ask anything that I might be able to answer. So thank you, and there's a bunch of bonus material afterwards in the session, but it's EO8. I would appreciate it if you'd fill out the evaluation and hand it over to the gentleman on your way out.
Thank you, Paul, good job.
I could write a script